Welcome back to problem number 2 in our uniform series payment problems, also known as annuity payment problems. So like I recommended in the prior video, I would recommend that you take a few minutes to read the slide, and I'll discuss the setup here, and that you try to solve this on yourself, solve this by yourself, press pause, and then come back to the solution after you have worked it out to see if you understood and worked it out correctly. So we have a situation here. Again, we're showing our cash flow diagram because we always want to have a cash flow diagram. And we see, now we know what our annuity is, what our annual payment is. It's $2,000 the end of every year. So you can see it's an even uniform annual payment over 30 periods. In this case, it's 30 years. Every year we deposit $2,000. We know our interest rate is 2% per year. Our payments are in years, our interest rate is in years. There's no talk of any compounding within the year, so we can make a safe assumption that our interest rate that we're going to use to solve the problem is also 2% per year. And what we're trying to find out is, given that we deposit $2,000 a year, the end of each year, because remember by cash flow diagram convention, these are end of period cash flows, end of period 1, end of period 2, end of period 3, etc. Through end of period 30, then what value, what amount are we going to have to withdraw to bring back to ourselves at the end of period 30. Now remember, in the setup for an annuity, in the way and the annuity formulas and then therefore the compound interest factors in Appendix C in your book are derived, is that an annuity states that there is no payment in period 0, no cash flow in period 0, a uniform annual payment, consecutive periods, whether it's 30, 65, whatever, consecutive periods. And yes, it knows that we're making a payment at the end of year 30, the exact same time we're taking the money out at the end of year 30. So that factor takes that into account, all right? So press pause and let's see if you can come up with the right answer in what the future value, what is the economic equivalence at the end of year 30 of 30 uniform annual payments given 2% per year. And then we'll move on. Okay, so let's see what we can find here. Get it set up. So we already kind of stated that the interest rate is going to be 2% because there's no statement about any compounding within the year. And our payments are annual. So our interest rate is stated per year. Our payments are per year, so those are consistent. And what we want to do then is find the future given the annuity. So we want to find the future given the annuity. So the annuity is given at $2,000, and here's our functional notation as stated by the engineeringandtrainingexam.com guy. We want to find the future given the annuity at the stated interest rate of 2% per year over 30 years. Now remember, the interest rate isn't always going to be years. The number of periods isn't always going to be years. It just happens to be in this particular problem. But we always want an interest rate that is consistent, coincides, whatever word you want to choose, with the payment frequency that's happening. Okay? So we know our annuity is $2,000. That was given that we're putting $2,000 in a year. And again, we go to the compound interest tables. If you prefer to use the formula, refer to the front cover of your book. Inside front cover of your book, or I believe it's Chapter 4 where the formula is. These are relatively hairy and complex, so that's why I prefer to use the compound factors in the table. But again, if you take this 2% and this N, I of 2%, and this N of 30 and plug it into the formula for finding the future given the annuity, you'll get this value of 40.568. So the tables just make it convenient that we don't have to go through those calculations. We can just look it up in the table. So again, if you go to Appendix C, the page that is 2%, the row that has N equals 30, go over to the column that is find the future given the annuity, you'll find a value of 40.568. So if we take our annuity of $2,000, multiply it by 40.568, that tells us that we will have a future value of $81,136. So what that means is $81,136 at year 30 is the economic equivalent of $2,000 a year for the prior 30 years at a 2% interest rate. Okay, So that's what our future value is. Those two values, those two cash flow streams, $81,000 at year 20 is economically equivalent at a stated interest rate of 2 years to a payment, 30 payments of $2,000 per year. And that is the second example. Thanks.